Yes.
Good. Then, thank you for doing that, by the way.
Yes. I was, Evelyn, I was telling Juan last week. So I have 2 other classes where we just started working in groups and no one was contacting anyone. So I got a hold of everyone and I said, okay, I'll do this. So I tried to do Google Hangouts and it was a disaster. It's like some people would get on at one point and then hang up and then other people would get, it was just terrible. And I texted Juan and I said, thank you, whatever you do. And I really appreciate it. I realize now how difficult it is.
Here's a little bit of humor for you too. So I usually say this whenever I have a group work. I guess it's humor for the teacher too because he's going to see this. But when I die, I would like everybody that I ever did group work with, like everybody, to lower me down into my grave so they can let me down one more time. So I don't think you guys will be in that group, just so you know. But everybody,
I hope not. But Juan, that's hitting really close to home with these other 2 groups. Oh, my goodness. I totally understand.
The first time I did Google Hangout, I had to do it for the other IT class. It was no fun. I was also like 48 hours without sleeping, and I had to focus in finding the way to do this hangout. And then I had to meet with these other 2 guys, and then it wasn't no. My computer microphone stopped working, and then they decided to, okay, just do it yourself. Just record it yourself. It's fine. We're just gonna do it 2 different. So, oh no, well, and I did it, and then I was trying to find out how to record it, and then they start doing all of these layer and then mirror. I don't know if you ever have that problem, Juan.
Yeah, I have a lot of problems.
And then the first time it will show up, and then will show up, and I was like, oh, what is that?
Oh my gosh, I don't even know how to record. I went looking for it, and I have no clue.
Well, it's not that's the confusing part. Is you have to do it through YouTube. It's not Hangouts actually. You have to.
Oh, that's right. We had to do that at the beginning. Okay. Oh my gosh, what a pain. Okay, yeah, you're right. Now I remember.
That's why.
Okay. Oh, I'm sorry. I went to the page. I did not open the quiz.
So would it be beneficial if all of us took a turn to get this hangout started so that we all know how to do it?
I know how to do it, but yeah, probably for Christina that she needs to do it for her.
And we can do that. I figured it out. So yesterday we did another Hangouts call and it all went really smoothly. So maybe it was just that day, but it gave me an appreciation for you, Juan. So thank you. But yeah, I mean, I'm happy to do it. I've got it figured out now. The recording, I would have to get a refresher on.
Yeah. Yes, I can text all you guys on the Hangout group chat the instructions for how to do it.
Okay. I mean, I would just have to look back to week 1.
Oh yeah, that's right. There's like pretty pictures on that and stuff.
Well, yeah. Still couldn't figure it out.
Okay, so lesson 10, I think it'd be very beneficial for Megan if we just kind of like we talked about the equations and why we use certain equations, so that way when she goes through and looks at this, she's not completely lost. And the videos, I'm guilty of not watching those every time, but wow, if you guys just watch those videos that he has for each lesson prep, man, that like that was very good.
Yeah.
Well, this one was okay. The other ones, I don't know. He went on the other ones. I didn't actually understand. I have to go through other videos on YouTube to understand it better. But this one was very good, actually. Yeah, you're right.
Okay, so starting with question number 3 on the lesson 10 group meeting quiz. It says find the margin of error for a 90% confidence interval where the standard deviation is 50 and the sample size is 25. So now there's some special numbers attached to the 90, 95, and 99%. right?
Yes.
Yeah.
What do we call those numbers again? They are called the
I know the symbols.
they are
It's
called
Sigma and, well, wait. No, that's the other one.
well, this is the
Variance. No,
you're
that's not.
testing us, Juan.
no, I remember it was like on there's a
The
little chart.
yeah. I'm
Okay,
looking.
so the 95, 90, and 99 are the confidence.
Oh, come.
But the numbers are the opposite of it. So anyways,
Confidence intervals and
they're called the Z star.
Yeah, the value is Z asterisk. So this one is a 95%. Well, let's just go through to make it easy. So 90%, I'm going to write it down here so I have it. 90% is 1.645.
Okay, I'm going to make that chart. So 90% confidence equals 1.645 Z asterisk.
Mm-hmm.
95% confidence,
is 1.96.
1.96 Z star confidence. And then 99% confidence equals
2.576. Yeah.
2.576 Z star.
Yeah.
Okay. So then we just throw those guys onto the margin of error.
Okay. I'll go back. Okay. So, oh, we're to 90%. Okay.
16.45.
90%.
Sorry, I need to go back to see the margin of error equation. Because all I can find is the interval equation.
So the margin of error is going to be the plus or minus.
So it's going to be the interval. I see. So
Well, wait a second. How's it? Okay.
Confidence level. Okay, so what you can do, so here is find the margin of error, confidence interval. And so every time you go to a lesson, you can, to find something, go Control F, type the terminology you want to find, and then you will be able to find that faster. Control F, type that, and then you're going to be able to find it faster.
Right.
So here is
Okay.
asking for the confidence interval.
Yeah, actually, so this one is asking for the margin of error, right?
And margin of error for 90% and the confidence.
And that is M is the margin of error equals Z star standard deviation over the square root of N.
Yeah.
So I was looking at the confidence.
okay. So that means Z star times, or sorry, it's going to be 1.645 times the quantity 50 over the square root of 25.
Mm-hmm.
And I get 16.45.
Yeah, me too. 16.45.
Which of the following statements is true?
Sigma square, interval estimator. X is a point of estimator of U.
Yeah, so X bar is a point estimator of that parameter.
Mm-hmm.
Yeah, that's what you call it. Okay, I will read the next one. Gina,
I'm sorry. Hold on. So with question 4, You're saying it's the
Yeah.
second one, right?
Yes.
Yeah.
Yes.
Okay.
Okay.
Go ahead.
So Gina wants to construct a 95% confidence interval for GMAT score. She knows the standard deviation is equal to 113. She collects the sample random sample size n equals 64 and compute x equal 526. Use this information for the next 6 questions. What is the point of estimate for the true GMAT score?
That's 526 is a point estimate.
Yeah, that's what well, yeah, it's no calculation there.
And then question 6 is the margin of error for 95% confidence interval.
Yeah, that will be 1.8.
Square root of 64.
Oh no, that's 27.68. Well, 27.685.
Yep, that's what I got.
And how many does it say decimals? Okay, so just 3.
I guess.
So then to get the lower, we just take our point estimate of 526 and we subtract 27.68. And I get 498.315.
Yeah, there you go.
And the upper is the opposite. We add 553.685.
Yeah, 685. There you go.
Whoa, we just did this confidence interval.
I thought that was going to be difficult, but well, usually the first lesson that when the new concept, they just want us to understand it. So that's a good part about this.
Okay, so this is one of those Christina questions. So we are going to increase the sample size, which is in the denominator with the square root.
Mm-hmm.
So what would happen if we increase, or what would happen to the width of the interval if we increased the sample size? Increase, no change, or decrease?
Okay. Are you asking me or just in general, just for the question? What happened to the width of the confidence interval?
Sorry. I just read the question.
They increase the sample size.
I think will decrease.
Would decrease.
Well, decrease. Try it. Let's put like what's a big number?
That's inversely related.
So it's inverse. So it should decrease then if we increase the.
It will decrease
because it's inversely related.
Right. And I mean, because if you think about it, if you only get 12 samples or you get 1,000 samples, your confidence interval should be a lot more narrow with 1,000 samples than with only 12. I mean, just generally speaking, logically. So, but if you increase that denominator, you're going to end up with a smaller number. Like you were saying at first.
Yeah,
Increase
I think
n, you're going to end up with a smaller number overall.
Right. I think at the end of the day, we're just making the denominator bigger or smaller, which means that those special numbers, those z stars, will be multiplied by either a big number or a small number, right?
Mm-hmm. Right.
Making the denominator bigger means the number gets smaller.
Mm-hmm. Means the confidence interval gets smaller.
It's when you are in a poor house and many people, and then you have to divide the food. If there are more people, the portion is gonna be smaller. That's
Exactly.
I tried to explain this to my niece. She's doing fractions, so
Okay, what would happen? Sorry, next question on number 10. What would happen if to the width of the confidence interval if we changed it to a 99% confidence?
that in that case will increase.
Increase.
Okay. I don't know if you want to read, Christina.
Sure. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number. So now we're doing the sample size.
What sample size do they need? Oh, that was cool. On the video, they gave us that cool equation.
Yeah, I was looking for that equation. That's 99%.
So we're looking at, go back and forth.
99.
So we're at 95%.
9,000 and 99,000. Yeah, because you have to.
Okay, sample size formula is n equals the quantity z star times standard deviation divided by m, all of it squared.
Right.
It's like 99,000,002.
What?
99,002. 90. Oh,
Wait, for what? So the 95%, the 95% confidence interval will be 1.96 times 400 is the standard deviation. All over 50 is the margin of error. Which I'm getting is 245.86. But you always round up. So I've got 246.
246.
What are you getting?
Oh, I got a huge number. I got 99,002.
So what numbers are you putting together? Because I did the 1.96 times 400 divided by 50.
No, I think I did this formula. I just.
And then you squared it?
Yes.
Yeah, I got 245.8624.
Yeah, that's what I got. Rounded up to 246.
Okay.
36.
Okay, my turn to read, I guess.
Okay.
Well, hold on. Evelyn, are you good with that?
Sorry.
Yeah, I'm fine. I just was doing the wrong formula because I just did the wrong formula, I think. Okay. Yes, you're good.
Go ahead.
Okay.
Juan.
It says the mean salary of actuaries is $100,000 of and the standard deviation is $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance 0.05. So that's 95% confident. And so you get your null hypothesis is 100,000 and your alternative is not 100,000. You collect a simple random sample, and it is larger than 30. And you get the X bar to be 111,000. Use this information for the next 3 questions. So we do the lower limit of this 95% confidence interval. So we do
That formula is
1.9, sorry?
Well, so the lower level is X bar minus Z star times standard deviation over the square root of n.
So 111,000 minus the quantity 1.95 times
1.96.
Oh,
You mean the Z star?
yes, sorry. 1.96 times 36,730 divided by the square root of
36.
See, that's the numbers that I was using before.
Okay.
I understand. And then I was just going one step ahead. That's why it didn't work out. Okay.
Yeah, there we go.
Did you get 98995?
No.
Dang it! I typed it in wrong.
Round to the nearest whole number. I've got $99,002.
That makes sense. Wow. Sorry. But I have this problem with this computer. Every time that I am watching something, it will go up or down. And
really? Yeah.
And then I was doing the other one and say, where you guys get those numbers?
Yeah. So I keep doing it.
That was just so embarrassing. I see, I don't see those numbers.
Okay, well, let's go through it one. Let's make sure that I'm doing it right. So I've got X bar is 111,000 minus the Z star will be 1.96 with the 95% confidence interval.
Okay.
Times standard deviation of 36,730 over a square root of 36.
Yeah.
So 36,730 divided by 6. Well, it gives you a number. 6121.6s forever times 1.96 equals about 11,998. And when you subtract that from 111,000.
Well, I have no idea what I did wrong.
Well, I find that I hit the wrong thing or hit a decimal too soon and it just throws everything off. It's just sometimes when I have a friend who calls it fat fingers. You're just hitting the wrong numbers.
Yeah. Okay, so now we're on the same number, 99002.
Yes.
Yes, there we go.
And then the upper limit is, I just added.
$122,998.
Mm-hmm. That's what I've got.
Now I'm doing with the right numbers. Sorry, guys.
Good. You got that one, Juan? I mean, I just want to make sure that.
I got 123005.
No, it's different than what I've got.
Dang it! What am I doing wrong? 36,750 divided by 6.
No, 36,730.
Yeah, The 95%.
36730 is the standard deviation.
Mm-hmm.
Oh, that's where I've been. Yeah. Okay.
I did that once where I wrote down one of the numbers completely wrong, and then it was like there were 5 equations, and I got them all wrong. I'm like, how is that possible? Well, because I wrote it down wrong. So, been there, done that.
Okay, so I got 1, 2, 2, 9, 9, 8.
Yes, that's what I've got.
It's a lot of money.
Yeah, you're right.
Yeah,
Oh,
if we can
guys,
convert
that's
normally. Do we get the money if we got the test right?
You're right.
Okay, so there are, sorry.
14 are the 3 requirements that need to be checked when computing a confidence interval for a mean. Simple random sample, sigma's known, X bar is normally distributed.
Yes.
I think all of the above.
Yes, and yes, all of them.
Oh, is that it? Are we done?
Yep.
Well, let's submit this puppy and see how we did.
Hey, we might be done in an hour.
That would be awesome.
Look at that.
We did it? How come mine's slower than yours?
Good
You're always
job.
so excited and I haven't seen it yet. Okay, sweet.
Oof.
Okay.
Yeah, so I formatted my computer so that I erased all the hard drive.
Yay.
It works really fast. So.
Good.
Yeah, so apparently you can't be saving stuff for 7 years on your laptop. You have to like back it up somewhere.
I guess that makes sense.
Perfect. Now we're going to get to the unknown sigma. Using the t-score.
Mm-hmm.
Oh, let me end this video and then I'll start a new one.
Oh, right.
Okay.
Thank you.
Thank you.